On July 1st, 2025, astronomers using the Atlas telescope in Chile spotted what at first looked like just another faint point of light. But as the data came in, the object quickly proved to be extraordinary. Its designation 3I Atlas carries weight in astronomy. The 3I means it is only the third confirmed interstellar object ever discovered, following the mysterious Oumuamua in 2017 and the comet 2I, Borisov in 2019. The C-2025 and 1 portion reflects its official comet classification, found in July 2025, and Atlas credits the asteroid terrestrial impact last alert system, which detected it. Atlas is specifically designed to spot unusual or dangerous objects early, and its discovery here underscores the program's importance. Unlike most comets cataloged every year, 3I Atlas immediately stood apart. It was on a path that couldn't have originated from our solar system. Right from the start, its naming signaled this was not just another icy body, but a cosmic visitor from deep interstellar space, a rarity of the highest order. Once confirmed, telescopes around the world and in orbit turned their gaze toward 3I Atlas. The Hubble Space Telescope revealed something striking. The object had developed a fuzzy coma halo of dust and gas surrounding its icy core, suggesting it was releasing material as sunlight warmed its surface. This is behavior typical of comets, but this comet was alien to our solar system. Estimates put its nucleus between 0.3 and 5.6 kilometers across, though most models suggest it is probably under 1 kilometer. Around that core stretched a coma nearly 15 miles wide, a cloud of sublimating ices mixed with dust. To see an interstellar visitor behaving like a classic comet was itself remarkable. Oumuamua, by contrast, had no obvious coma at all. Still, its open-ended trajectory confirmed its foreign origin. This was a comet born far beyond our sun's influence, carrying with it materials and structures that may be unlike anything in our cosmic neighborhood. Its physical presence was both familiar and profoundly alien at the same time. What made 3I Atlas a true puzzle wasn't just that it came from outside the solar system, but the odds-defying nature of its orbital path. Its inclination of 175 placed it nearly in the same plane as the planets, but moving retrograde, that is, against their normal orbital direction. Statistically, the chance of such an alignment for an interstellar object is about 0.2%. That's already strange, but things grew stranger. Calculations revealed that as 3I Atlas sped through the solar system 58 kilometers per second, it would pass near not one, but 3 major planets: Venus, Mars, and Jupiter. As the orbital models were refined, scientists realized that 3I Atlas wasn't just going to cruise by the solar system, it was going to cut through the interplanetary neighborhood in a way that seemed choreographed. In October 2025, it will pass within about 30 million kilometers of Mars, which on astronomical scales is a near miss. Its encounters with Venus and Jupiter will also be unusually close, each interaction bringing it into ranges rarely seen for natural interstellar visitors. For most comets, a single close encounter with one planet would be remarkable. 3-in-1 trajectory is nearly unheard of. Compounding this is its incredible speed, 58 kilometers per second, the fastest of any interstellar visitor we've tracked. The result is a series of planetary flybys that not only defy odds, but seem imbued with precision. To planetary scientists, this isn't just a curiosity, it's a call to pay attention. Every one of these near approaches presents a fleeting chance to collect valuable data, but also amplifies suspicions about the nature of its path. The strangeness of 3I Atlas' orbit has naturally led to speculation that it may not be entirely natural. Among those willing to consider bold ideas is Harvard's Avi Loeb, who argues that if someone nor something wanted to design a probe to observe our solar system efficiently, they might choose exactly this kind of trajectory. The path is retrograde yet coplanar, ideal for maximizing planetary encounters. Even more suspicious is the timing of perihelion, when the comet is closest to the Sun. For Earth-based observers, this crucial moment will be hidden behind the Sun's glare, effectively shielding the object from our best telescopes when it could be at its most active. Loeb suggests this looks like deliberate stealth design, the sort of maneuver that would both maximize data collection from planets while minimizing the risk of detection. While mainstream astronomers remain skeptical, the improbability of the orbit combined with this near-perfect timing keeps the door open to more exotic explanations, from engineered probes to unknown astrophysical phenomena. The United States Space Force plays a quiet but critical role in this story. Beyond tracking satellites and space debris, its mission called Space Domain Awarenesses to detect and analyze anything unusual in near-Earth and deep space. Its Space Fence radar system, located on Kwajalein Atoll, can detect objects as small as a marble, continuously scanning for anything unfamiliar. Alongside it, the Deep Space Advanced Radar capability DARC in the US, UK, and Australia monitors more distant orbital zones. These systems are designed to catch precisely the kind of anomaly 3I Atlas represents. Reports circulated that Space Force had not only tracked the object, but also intercepted a possible signal associated with it, something that threw astronomers into debate. While no public evidence has confirmed such a signal, the infrastructure to detect it certainly exists. If true, it would mean 3I Atlas isn't just passing silently, but potentially broadcasting or reflecting something unexpected back toward Earth.
The idea of an intercepted signal tied to 3I Atlas raised eyebrows. But astronomers know better than anyone how deceptive cosmic static can be. Detecting an actual transmission involves a strict checklist. First is Doppler drift, the frequency shift expected when a source moves relative to Earth. Then comes repeatability. A true signal should reappear under repeated observations, not vanish after one detection. The on-off test compares data when the telescope points at the target versus blank sky. Modern observatories also use machine learning filters to sift millions of data points, discarding interference from satellites, aircraft, or even mundane electronics like microwaves. Past experiences such as the 1977 signal or the BLC-1 case in 2020 prove how often promising detections collapse into misidentified terrestrial interference. This is why even if Space Force or radio astronomers did hear something unusual from 3I Atlas, they would demand extreme caution. And weeks, if not months, of verification before labeling it an anomaly. To bring clarity to the debate over interstellar oddities, Avi Loeb proposed a classification system now known as the Loeb scale. It ranges from 0 to 10, rating how strongly an object deviates from expectations for natural comets or asteroids. Both Oumuamua, Mua, and now 3I Atlas have been rated at level 4, which indicates they display multiple persistent anomalies that resist conventional explanation. For 3I Atlas, those anomalies include its retrograde, near-coplanar orbit, its sequence of planetary flybys, its perihelion hidden behind the sun, and its potentially large size compared to previous interstellar visitors. A level 4 rating doesn't prove anything artificial, but it does highlight the need for rigorous, continued monitoring. It says, in effect, this one doesn't fit neatly in the natural box. For many scientists, that alone is enough reason to dedicate telescope time, radar sweeps, and computational models to follow the object's every move. Even as 3IATLA stirs debate, the next decade promises far more opportunities to study interstellar objects. The Vera Rubin Observatory expected to begin operations in 2026, will scan the southern sky every few nights with the largest digital camera ever built for astronomy. 3.2 gig. Rubin is expected to detect dozens of interstellar visitors every year compared to the handful seen so far. Meanwhile, the Square Kilometer Array, spanning South Africa and Australia, will become the world's largest radio telescope, with sensitivity high enough to detect faint hydrogen signals from the early universal narrowband transmissions, hinting at technology. Together! These instruments will give astronomers the ability to cross-check anomalies at unprecedented speed and precision, where 3i Atlas is one tantalizing puzzle. Rubin and SKA promise a new era where such puzzles become common, and where answers may finally emerge from the static. For now. NASA and the International Astronomical Union (IAU) maintain that 3i Atlas is a true interstellar comet on a hyperbolic trajectory, destined never to return. Its velocity of 58 kilometers per second, its cometary activity, and its alien orbit all fit that profile. No publicly released or declassified data confirms that Space Force intercepted a genuine transmission. Still, the improbable trajectory and planetary alignments leave the mystery wide open. Peer-reviewed science demands skepticism, and so most astronomers hold to the natural explanation. Yet, the object's rare characteristics ensure that the conversation doesn't end there. 318 TLAs is both a triumph of modern detection technology and a reminder that the universe still holds secrets we can barely interpret. It straddles the line between natural wonder and speculative anomaly, and as it continues its one-way journey through the solar system, it challenges us to watch, to listen, and to stay open to the possibility that not everything we encounter is as simple as ice and rock.